I need to buy white wine. I have white wine. Ooh. Okay, so this is what I did. If the sun is 93 million miles away, says NASA and all of the scientists, and also Wikipedia and all the science websites, then we should be able to totally figure that shit out.
Hello, and welcome to Flat Earth vs. Round Earth. That last clip is from a flat earther named Orphan Red. She has a more lighthearted approach to the topic, which is a refreshing change of pace. Flat Earth seems to strike a nerve with many people, so everyone just take some deep breaths and look at these adorable puppies. Oh, look at the little puppies. You little cuties, aren't you? Yes, you are. Yes, you are. Okay, so let's roll right into analyzing some Orphan Red videos. First on the list is her distance to the sun video. To quickly sum up her argument, she uses an equilateral triangle to calculate the distance to the sun. An equilateral triangle means that all three angles are 60 degrees, which means all three sides are the same length. In her example, she uses two locations where the sun is 60 degrees from the horizon at the same time. One in Macapa, Brazil, looking east, and the other in Malabo, Equatorial Guinea, looking west. She states the distance between the two locations is 4,134.6 miles. Therefore, because math, the sun is not 93 million miles away. Pretty straightforward. Now let's move on to the fun part. And by fun, I mean a lot of math. Woohoo! So at the end of her first video, she explains that if she used the same calculations on the ball model, the lines would never converge, which makes the ball model impossible. She further explains her math in her follow-up video where she shows some illustrations. So first, let's break down her circle illustration. She's using a radius of 3,959. The circle is split up into 6 sections, creating central angles of 60 degrees, and the chord of the arc creates an equilateral triangle. After checking the math, I actually got slightly different results. An arc length of 4,134.6 miles did not equal 60 degrees. Using a radius of 3,959 would equal a circumference of 24,875. Divide that by 6, which is 4,145.8 miles. To calculate the angle from her arc length, we can use the arc length formula, which is the arc length divided by the radius multiplied by 180 over pi. So 4,134.6 divided by 3,959 times 180 over pi equals 59.837 degrees. With this angle, the lines would eventually converge, but only at a distance of over 1,000,000 miles. She then continues by showing her calculations using the flat earth model. I got the same answer she did by using the Pythagorean theorem. Just divide the triangle down the middle to get two right triangles. Setting up the equation would be a squared plus 2,067.3 squared equals 4,134.6 squared. Isolate the a squared by subtracting from both sides, then square root it, which equals a distance to the sun of 3,580.7 miles. I thought she had a great idea, so I wanted to try it myself and see if I can get a similar answer. Using suncalc.org, I set the date to March 20th, 2015, during the vernal equinox, where the sun is directly over the equator. I found the exact location in Brazil where the sun is 60 degrees above the horizon looking east. I did the same thing for Africa looking west, which turned out to actually be a little offshore. In Google Earth, I used the latitude and longitude to pinpoint the exact locations. Using the ruler, the distance turned out to be about 4,150 miles. Using the same method as before, I got a distance to the sun of 3,594 miles. So mine and Orphan Red's calculations are really close, within a dozen miles of each other. But from my understanding, the accepted distance to the sun in the flat earth community is approximately 3,000 miles. So unfortunately, both our calculations are off by nearly 600 miles, if that's correct. Now on to the fun part. Everybody loves trigonometry, right? Orphan Red says that ball earthers need to factor in the oblate spheroid shape because using a perfect sphere could make converging lines become diverging lines. She's absolutely correct. Even a difference of 0.1% could throw off the math. This is one of the times I need to be as precise as possible. So according to Google, the circumference at the equator is 24,902 miles. Divide that by 2 pi and we get a radius of 3,963.276 miles. Using the distance of 4,150 miles, I calculated the angle like before, which comes out to 59.9952 degrees. Since this makes an isosceles triangle, We can calculate the other angles by subtracting the angle from 180 and dividing by 2, which equals 60.0024 degrees for both sides. Then subtracting that from 90 gives us the adjacent angle of 29.9976 degrees. Adding that to the 60-degree angle to the sun gives us one corner of the right triangle that is formed, which is 89.9976 degrees. I use trig to calculate the adjacent side. The cosine of the angle times the radius equals 1,981.5 miles. Then finally, to calculate the distance to the sun, take the tangent of angle 89.9976 times 1,981.5, which comes out to over 47 million miles. But that is only half of what it should be at 93 million miles. Whew, is everyone still with me? Orphan Red makes it a point to address that the accepted angle is 89.9986 degrees and asks why it's such a precise number. She goes on to say that would leave the remaining angle at only 0.0024 degrees. So how small must the sun be to fit inside the angle? Well, calculating the distance works the same on both models. It is just measuring the distance from the surface of Earth to the center of the sun, so the whole sun wouldn't have to fit inside of the angle. Going back to my illustration, if I use the accepted angle of 89.9986 instead, I get a more accurate distance of over 81 million miles. It's crazy to me that adding only 0.001 degrees changed the distance by 34 million miles. So overall, this doesn't seem to be the most accurate way to do it. On both Earth models, Orphan Red and I were incorrect with each of our respective calculations. When it comes to distance to the sun, it seems like you would need some really extreme precision when calculating it this way. The next video I was asked to analyze was uploaded by a YouTuber named Refi. He analyzed the 73-mile rocket launch video uploaded by Kai Michelson. He explains that he watched the video 100 times trying to analyze the curvature without much success, but then he noticed the moon was clearly visible. According to his calculations, the moon should be on the other side of the globe Earth model. Using information from the video, he calculated the moon's location on timeanddate.com. The result was that the moon would be over Australia at the time and impossible to see from Nevada, where the rocket was launched. To get a better visual, he used solarsystemscope.com, and using the results from before, he shows that the moon should be hidden by the curvature of the Earth. If he's right, then this is some amazing evidence the Earth is not a globe. To test it, I decided to start by doing the same thing he did. According to Kai Michelson, the rocket launch took place on July 14, 2014 at 7:32 a.m. Pacific Time. It was launched from Black Rock, Nevada, and achieved a height of 385,800 feet above sea level, which is about 73.1 miles. I couldn't find a more exact location anywhere, so I just used the coordinates from Wikipedia, which are north 40 degrees, 52 minutes, and 59 seconds, and west 119 degrees, 3 minutes, and 50 seconds. The time zone for this location is UTC-7 in the summer. The closest city to this location is Gerlach, Nevada, about 23 miles southwest of the coordinates. Starting with timeanddate.com, Black Rock, Nevada was not an option, so I used the closest location, which appears to be Reno. After entering the date and time of the launch, the moon's location appears to be east of Australia. Clicking the link under the map key that says "See where the moon is over the horizon" brings you to the Moonlight World Map. On this map, it does appear that the moon would be visible during the launch. Going over to solarsystemscope.com, I entered in the date and time information. It uses the local time zone of the user. So I set the time to 9:32 a.m. so it would be 7:32 a.m. in Black Rock. Clicking on the telescope icon displays a view of the sky from Earth. After entering in the location, it displays the moon visible over the horizon. Solar System Scope also has a sun and moon calculator, where I entered in the same information. This results in the moon being visible at 9 degrees over the horizon. So kind of a bummer so far, but just to make sure, I checked a few other websites. According to calsky.com, the moon would be visible at an altitude of 8.6 degrees to the horizon. It also displays an image of what the moon would look like, which I thought was pretty cool. Moving over to mooncalc.org, it gave me a time zone of UTC-5, so I had to subtract an hour, so it was 7:32 a.m. in Nevada in the summer. It calculated the moon visible at 9.46 degrees above the horizon. Finally, the last one I looked at was a 3D solar system simulator on brightonastronomy.com. After entering in all the information, I entered into planetary view. I made sure it was in Pacific Standard Time and changed the distance and size settings to 100% true. The moon does look like it most likely would be visible. The simulator also has a panoramic view, and this showed the moon visible above the horizon as well in the same location as Solar System Scope did. So unfortunately, after receiving similar results from 5 different sources, I'd have to conclude that this proof is false. Even Kai Michelson commented on the video saying the moon was visible from the surface at an elevation of 9 degrees. But it was a good video regardless, and definitely had me excited to check it out. And it looks like we have our first ever proof bonus round. So I figured I'd take a quick look at a video from the comments posted by Aaron Dover. He said it's new irrefutable proof of the flat earth, so I wanted to check it out. In the video, he shows that Koh Tao is visible from Koh Samui. Distance to the island is about 60 kilometers, which is 37.28 miles. According to this elevation map, Koh Tao has a peak of 380 meters, which is 1,247 feet. Using the calculator and inputting an eye level of 6 feet, an island height of 1,247, and a distance of 37.28 miles, over 460 feet of the island would be visible. I didn't see any information about the elevation of the camera, but looking at the video, he seems to be fairly high up. If the camera is at an elevation of 20 feet, then over 570 feet of the island would be visible, and over 700 feet would be visible at 50 feet. So detailed information about the camera location and elevation would be very beneficial for future observations. I think he's on the right track, and he has good potential to prove his theory. I personally would be interested in seeing what it would look like from several different elevations. If the Earth is a globe, going from 100 feet to 1 foot above the water would be a difference of 450 feet of visibility. I personally think that should be a visually noticeable difference. And that concludes the proof bonus round. So in this video, the last proof I was asked to analyze is a very popular one. In the DogCam balloon footage video, there appears to be a hotspot on top of the clouds. The argument for this video is that the circle of light on the clouds is a hotspot because the sun is directly above it. Also, the sun would not appear that large on the ball model. They claim it could not be a reflection because reflections move with the observer and the light appears to stay in the same place. I have also seen many opinions about the horizon line. Some say they see a curve, while others say they see a flat line. In the interest of time, I'm only going to analyze the 30-second section of the video with the hotspot. But first, in order to thoroughly analyze the footage, I need to get as much information from the balloon launch as possible. According to the video, the balloon was launched at 5:24 a.m. at the Wasbeck launch site near Neumünster. Neumünster is an urban municipality in Germany with a time zone of UTC+2 in the summer. I could not confirm the launch date, but the video was uploaded on April 28, 2011. During the part of the footage with the hotspot, the description states that at 7:11 a.m. the camera is at an altitude of 23,800 meters, which is 78,084 feet. So I think the best way to visually analyze the footage is test how it would work for each model. First off, I'd like to know the sun's location. According to timeanddate.com, on April 28, 2011 at 7:10 a.m., the sun would be located over Thailand. The land distance from Neumünster to Thailand is about 5,400 miles. I would like to test the flat earth model first. I plotted the locations of the balloon and sun on the map to get a better visual understanding. I also created an illustration to accurately display sizes and distances. In Illustrator, I created an artboard with a height of 4,320 pixels and a width of 7,680 pixels, so it will fit the 16:9 aspect ratio of the video. Fun fact of the day, this is also the resolution of 8K Ultra HD televisions, which apparently you can purchase soon from Sharp for only $133,000. The more you know. Anyway, on this scale, 1 pixel equals 1 mile. This is the location of the camera, 78,084 feet above the Earth, with a diameter of 30 feet. This is the location of the sun 5,400 miles away at a height of 3,000 miles and a diameter of 32 miles. As I zoom in on the camera, you can see how small 30 feet is on this scale. The white line represents the clouds at an altitude of 40,000 feet. Now we can compare the illustration to the balloon footage. So my first thought is that the sun looks lower than 3,000 miles. The sun also appears to be kind of big. It's hard to tell from the illustration because the camera is so small, so I made a different illustration of a 6-foot man next to a 32-mile diameter sun. Seeing just how massive the size difference would be, I would say it might be possible for the sun to appear that large from our perspective 6,000 miles away. Referring back to my first point, if the sun is directly over the hotspot, then that seems to create some issues for me. If the sun is 32 miles in diameter, and even if we consider light hitting the camera lens distorting the size, it still only appears to be a few hundred miles above the clouds. Mathematically speaking, the sun should be at an angle of about 29 degrees above the clouds. Looking at the video, as the camera moves up and down, I would say that it could possibly be 29 degrees. So this leads me to my main issue I'm having with the model. In the video, if we're seeing a distance of 3,000 miles from the hotspot to the sun, then the sun would only be the size of this dot. 32 miles is just 1% of 3,000 miles, so this little dot is 1% the height of the line. I just can't seem to think of anything that would increase the sun's apparent size by 6,000%. So this leads me to believe that the light we are seeing in the video is most likely a reflection and not a hotspot. I don't think the reflection would move because the camera is barely moving compared to the 6,000 mile distance to the sun. I also think it's a reflection because the description says that this is a view over the Baltic Sea, and zooming in, the clouds seem to end right here. A reflection would also explain why the sun looks so close to the clouds. In the flat Earth model, the sun always disappears much farther away than the horizon, so it would appear much closer to the horizon. This seems to make the most sense with what we're seeing in the video. Moving on to the ball model, I entered in the date, time, and location on SolarSystemScope.com. Night Monster is 7 hours ahead, so I set the time to 12:11 a.m. so it would be 7:11 a.m. there. Using the sky view, the sun is barely over the horizon. This looks close to what I'm seeing in the balloon footage. To double check, I also entered in the information in the 3D solar system simulator. This also showed the sun visible just above the horizon, which also makes sense with the video. What I really thought was interesting is the Earth would be spinning about 609 miles an hour at 54 degrees latitude. That is about 900 feet per second. In this clip, we see the reflection for about 4 seconds, which means the light should be moving across the clouds and water by 3,600 feet. But even with zooming in and slowing down the footage to 30%, it still doesn't seem like it's moving to me. But then again, I'm not sure how visible the small distance would be over the huge distance we see from the camera. So the only other thing I can really check is the horizon. This footage does not appear to be distorted like others I've seen. The DogCam sign and the armbar that holds the camera look straight, so I guess it could be argued that the footage is visually accurate. One way to test it is to use my round Earth model. At 78,084 feet, the horizon would be at a distance of 343 miles. According to the model, the curvature over a distance of 343 miles would look like this. I'm actually pretty curious to see how my math and model match up with the footage. To compare it to the video, I opened a screenshot of it in Photoshop. I removed the text line and white background and made it 50% transparent. I took 3 random screenshots of the footage where the horizon looked a little more defined. I increased the contrast to see the horizon better and rotated them to place the peak of the arc at the top. And I thought this was pretty cool. Comparing my image to the screenshots, they seem to line up surprisingly well. Now I have heard arguments that the video is fake, which might be true. I really don't know. But if the video is actually real, the sun position and horizon do seem to be displayed correctly according to the sphere model. But overall, this is only one example. I still need much more evidence supporting either model. More importantly, what do you guys think? I feel like this one was pretty interesting. So at the end of round 3, the contenders are just getting warmed up. Looking at the fight recap, 1, I thought Orphan Red's method of calculating distance to the sun was very clever, but it seems you would have to have some extreme precision to get an accurate calculation on either model. 2, unfortunately, this proof does not appear to be correct, but I like that he did some detective work and investigated what he saw. 3, without more information, all I could do was calculate if it's possible for the island to be visible on the sphere model. I hope he gets a chance to go out and do more observations. I'm very curious what his results will be. And finally, the flat Earth model seems to work better with what we're seeing in the video if it's a reflection and not a hotspot. On the sphere model, the horizon appears to match up correctly, but I don't see any visual evidence of the Earth spinning. Either way, I had a lot of fun analyzing this video. And as always, please do not hesitate to comment and provide feedback. We can have a discussion, find topics for the future, fix any mistakes, or talk about how I didn't get enough sleep last night. Thank you guys so much for watching, and I hope to see you for the next round.